In this problem, we got a collision experiment that is equipped with gliders A and B. We know that glider A has a mass of 0.50 kilograms and glider B has a mass of 0.30 kilograms, both moving with initial speed of 2 meters per second. What we want to find is the final velocity of the joint gliders and compare the initial and final kinetic energies. So before we have the object A moving to the right with a velocity of 2 meters per second, and of the object B is moving to the left, approaching to object A with a negative 2 meters per second because it's going to the left direction. Same thing as we saw in the last problem is that the total momentum before the collision is going to be equal to the total momentum after the collision. So now we can solve the problem. So what we're gonna do is add up the momentum of the object A to the momentum of object B. That should be 0.50 kilograms times 2 meters per second plus 0.30 kilograms times negative 2 meters per second. And all of that is going to be equal to the added two masses, 0.50 plus 0.30 times the final combined velocity. As we solve for the final velocity, we should get 0.4 divided by 0.8, and that should give us 0.5 meters per second. The positive answer means that the final combined velocity would move to the right, to the positive direction. In regards with the kinetic energy, as we separated, the kinetic energy of A is going to be 1/2 mass times its velocity, the initial velocity squared. It's going to be equal 1/2 times 0.50 times 2 squared, and that should give us 1.0 joules. For the initial velocity of the object B, we have 1/2 its mass times the velocity V squared, which is 0.60 joules. As we add them up, we get the total kinetic energy of 1.6 joules. For the final kinetic energy, we use the same formula, 1/2 times mass times velocity squared, but in this case, we combine the two masses and we multiply by 1/2 and times the final velocity 0.5 squared. So we get as a result the final kinetic energy being equal to 0.10 joules.